Alright guys, I started the recorder 5 minutes late, so be sure to read the first page of the notes. Also be sure that you have read up to page 20 of the PowerPoint and keep going, because that's where we are. Abstraction is the idea that once things are broken into modules, you don't care about the details. You don't need to know how a turtle draws. You just get to say, okay, make me a turtle and make him go forward. You know, that's a miracle of programming, a miracle of modularization. You know, in 5 minutes we get to draw circles and stuff like that, where it would take hours and hours of programming otherwise to learn how to do it. Modularization lets you reuse work. Once you come up with a turtle class, you can reuse it over and over. Once you come up with a class that calculates interest, I keep using the word class, I apologize. Once you come up with a module that calculates interest, then you could, reuse that. If you come up with a module that does some input and then make sure that the user doesn't type in an error and handles it if they do, great, you can use it in your other code. So it allows individual modules to be used in a variety of applications. Many real-world examples of reusability, like math. People write math libraries, to do specialized math calculations. Python comes with the math library. It also comes in with, a lot of functions just built right in. But, if you need to do square root, yeah, you can hack the exponent function to do square roots. I think most of y'all know that, but if you need to do this, a is the square root of 90, then you could do this. A is equal to 90 to the power of 0.5. Raising something to the square root of 1/2 is, raising something to the power of 1/2 is the same thing as taking the square root of it. But it'd be nice just to have the SQRT function available to you, so that you don't have to word it like that. Not everybody will recognize and it's part of the math library. So if you wanted to do that, square root is a module in the math library. So in your code, up at the top, you could do import math, and then you could do math.square root whenever you wanted to. A is equal to math.square root 90. It's an advantage of having modules. You don't have to know how to write a square root function, which is really annoying if you don't do it like that. If you have a language that doesn't support exponents, which is, quite a few of them, if you had to write the library yourself, it'd be really annoying. If you had to write the module. Keep using those terms interchangeably. A library is a collection of modules. Turtle is a collection of modules. Reliability, you can test it. You don't have to worry that your function, that your module for calculating the average of a series of numbers is correct if you write it once and you've tested it. Yeah, you ought to kind of make sure it works, but, when you use it again, just kind of eyeball it, give it, 8, 9, and 10, and make sure that it says the average is 9. But you don't really have to sweat it. Once you write a module and you've tested it thoroughly, then you can bring it into your new program with a minimum of worry, which is a good thing. Right, because you're trying to write your program so that it works well, and the more code that you can use that has been previously tested, the better off you are. So advantages of modularity. Reuse of modules, team development, because you can have one person write one module. Reliability, rapid development by relying on them. And lastly, abstraction. Not having to know the details about how to do something complicated. Like taking the sine of it, I'm sure that there's a formula for calculating the sine of, 78 degrees, but I don't want to have to know it. I just want to call a sine module. So modularizing a program, you have a main of your program and then you have modules. And I didn't see this in any assignments that I've given so far in this class, but it could be because the other classes had more assignments. That's probably the case. You can mix in Python your modules and your main code. You can't do that in a lot of other languages. But I'm going to give you an example. If you did this, you know, x is equal to input, what is your weight? And then you did y is equal to input, what is your height? You know, this is just that BMI program. And then you had a function here, def calc BMI. And would you use single letter variable names? No, those are bad, you know, variable names. And then it calculated BMI, you know, by whatever formula. BMI is equal to x divided by y times y, you know, times 703, whatever. And then return BMI. And then so you say z is equal to calc BMI. No, we've already done that. Yeah, calc BMI x comma y, and then you print your BMI is comma by z. That is valid code in this language. But it's ugly because we've defined a function right in the middle. Your functions ought to be defined towards the top of the program. So the way your code usually looks is you put your imports on top, then you put your constants, declarations up at top, then define your modules, and then finally your main code. And once you become even more awesome, you'll put your modules in separate files so that you could do, you know, import my math library. And then you could, you know, reuse that math library that you've written in a whole bunch of other code. But this is the standard way of doing it. Just because Python lets you do other things doesn't mean that you ought to do it, because it's not supported in other languages, a lot of other languages anyways. Don't mix your module definitions with your main code. Put it above. And that's what the book means by, well, it doesn't say it. But a module is defined by the header at the body and the return statement. So in this code up above, define calc BMI, x comma y, that's the header. And then when I did BMI is equal to whatever, you know, the equation was. And I got it wrong even. No, I guess I got it right there. Why don't I just copy this? That's the body. In this case, it's only one line. Usually, if something is only one line long, you consider not making it a module. But if it's a mathematical formula, it's fair to go ahead and make it a module anyways. And that's the return statement. Those are the three parts of a module, just like in a flowchart. DEF, and then some code, and then a return. In Python, you can leave out the return statement if it's not returning a value. You know, like if you have a draw square module, whatever. And it takes an x and a y coordinate and a size, and it does some magical stuff. In this language, you can leave off the return statement, and that's true of C, C++, Java. If it's not returning anything, it's called a void function. Textbook doesn't mention that yet, but a function module that doesn't return a value is known as a void function. A lot of textbooks will call a function that does return a value, like this one, as a fruitful function. That's a silly term, right? It's full of fruit. But anyways, that's what they called it. A function that returns a value is known as a fruitful function. A function that doesn't return a value is known as a void function. void functions in many languages, including Java, excuse me, including Python, also teaching Java today, don't need the return statement. Why? Because it's kind of meaningless. Because you know that a return has to happen the next time it finds an unindented line. That's how this language marks the end of a block of code, is when it finds an unindented line, it says, okay, that's the end of the module. But in our flowcharts, we go ahead and we stick the return down at the bottom anyways. Just because flowcharting and programming languages are not the same. Same for pseudocode. But do put a return in your pseudocode and flowcharts anyway. So modularizing a program, we know how to do that. You call the module. We have a DEF here, a draw square. So, you know, draw square, something starting at position 0, 0 with a size of 100. You know, Z is equal to calc, BMI, you know, X comma Y. Call the module. When you call a module, you use its name, followed by parentheses, and in parentheses you pass any arguments that are required by the module. How do you know if the module needs arguments? You scroll up and you look. Draw square requires 3 arguments. How do I know that? Because it's got 3 parameters defined. They just give them different terms. When in your module header, they're called parameters. When you call them, they're called arguments. Why is there a different term for them? Because they are different things. These are values. They could be other variables, like they are here, or they could be constants, you know, unnamed constants like that, or they could be anything. But up here, when we define our module, they are variables. They're variables that get values from the call of the function, right? So if we call BMI, then we're going to be passing in somebody's height and weight. Those values could be hard-coded, or they could be variables, they could be anything, but once we're inside the module, they need to be stored in variables so that we can do stuff with them. So, just remember that. The values inside the parentheses are called arguments. They're called parameters in the module. If you mix them up in casual conversation, like you talk about this, you know, with your kids or your spouse or, you know, whatever, your parents, your best buddies, yo, I'm going to call some parameters and argue, you know, who cares? But for test purposes, you'd want to know that when you're speaking and trying to talk very literally, very precisely with another programmer or an instructor or something like that, then you want to use the correct terms. But you'll see me mess it up here. I'll say, okay, I'm going to pass in 3 parameters. I passed in 3 parameters. Well, what I did is I passed in 3 arguments that fill the 3 parameters here. That's the correct way of saying it. But, you know, people get lazy when they're talking casually. I'll try to correct myself, though, because I don't want to talk bad and then ask you a test question about it and encourage you to make the mistake. We know how to diagram modules. We know how to flowchart them. When you have a module call, if it's a module you wrote, you put it in a rectangle with bars. Our flowcharting program has vertical bars. The book shows a horizontal bar. And then when you actually flowchart the module itself, you start it with a terminator, but you don't put start, you put the module name. I like putting DEF in front of it. Unnecessary, according to the book, either's fine. And you have a return statement at the bottom. Now this thick line here, you don't actually put in your flowchart. You could, but This module could be invoked from 20 different places in your module, and you don't want thick lines going all over the place up to the top of here and then back there. That's just for the book's purpose, showing how it works. When you call display address info, it runs over here, it starts working, and then it comes back. It's like you handed somebody a map, told them to go to Walmart, so they ran to Walmart, they bought everything you needed, and then they came back with it. Yeah, but we don't need those thick lines. We didn't do those thick lines when we diagrammed our own module with a flowchart in class. I'm not going to count you wrong if you draw those lines, though. I try not to be a jerk. I mean, I can't help it, but, you know, try not to be. In your module, you declare some variables just like you do in your main code. But those variables are not visible outside of the code. And I'll show you what I mean. Now, what equation am I going to come up with? Define get area. This is the area of a circle, just because we love circles. Okay, so we're going to say x is equal to radius times radius. And then we're going to say area is equal to x times pi, right? And then if I do this, in my main code, if I get, you know, whatever, I'm just going to do that. Pretend we're doing pseudocode here. I forgot to return the area. Then I guess I should, you know, do this for reals. The radius is going to be equal to 100. The area is going to be equal to get area of that radius that we pass in. Then we're going to print the area out. If I was curious about this value and I thought that I could print it out here, I can't. Because we defined it inside that module, it's not available anywhere else. It's like this is a house. We have some furniture in the house, but you can't sit in that furniture when you're standing outside the house. So since x is defined here, we can't use it down here. Well, how come you can use area here? Because we returned it, right? Notice that this argument has a different name than this parameter. They don't have to be the same. You know, we could pass in a value there. We could pass in an equation, you know, 5 times 25. We could pass in a variable. The variable name doesn't match because variable names, the language doesn't care about them. If instead of calling this radius, I wanted to call this Lady Gaga, and so then I used, you know, Lady Gaga everywhere it used the word radius. This is stupid, right? But I could. It would still work. I just messed up something. That's valid code. It's nonsensical, but it's valid code. Because the variable names don't matter to the programmer, they just matter to us. And everywhere we're always storing height and weight in single letter variable names, that's really bad programming. I should always use words that are descriptive. All right, let's fix that. When I do the notes in Notepad, I shouldn't do that because if I need to undo, I can only undo one level. It's a disadvantage of Notepad. But Word, you know, capitalizes things when I don't want it to, and, you know, inserts smart quotes, and you have to specially configure it to avoid it from doing that. So I go ahead and use Notepad. But it'd be a good idea to save occasionally. What if my machine crashed? Let's just put March 6th. That's called its scope. Not sure why they call it scope. I'm sure that there's a great reason for it. But the scope of that variable right here is limited to the getArea method. Now, if you want, you can define variables above the modules, and then you call those global variables. So I could define pi up here. Pi is equal to 3.14159. And it is available everywhere. It's available here if I wanted to use it down here. So this is a global variable. Use global variables sparingly. I use them all the time when I'm doing turtles because, anyways, We'll talk about why. But use constants make great global variables. But if this actually needed to change a global variable, you have to do something special in Python in order to get that to work. So basically, you should treat global variables like they're read-only, or that they're only changed in the main code. So this is what's known as a local variable. A local variable is one that's defined within a function. Excuse me. Yeah, within a function. Let's go ahead and put that comment down here. It is available only within that module. If you want to use it elsewhere, you have to return its value. Hope that makes sense. It will make more sense as you do programming, as you become more skilled. So, where the variable is available is called its scope. In the example above, X's scope is limited to the calc area function. Modules can be self-contained units that are easily transported. If I write a good module, I ought to be able to copy that calc area method. Excuse me, that's what they're called in C++ and Java. That calc area function, that calc area module, and put it in another program. Ought to work pretty easy. The only problem is that it doesn't have pi defined, so you'd still have to define pi before it would work. That's what easily transported means. If you write a bunch of modules, but it's very difficult to get them to work in a new program, then they may not have been very well designed modules. So global variables and constants, you declare them at the program level. What does program level mean? It means that they're not indented in this language. So up here, I defined pi here. This is a global variable because it's unindented. All of your main code is unindented. Well, at least it starts unindented in Python, not in pseudocode. Don't like that distinguish. I'm using the wrong word. I don't like that being distinguished between the two, but we got to do it. We have to follow the rules. Honestly, I'm going to wander away from using pseudocode as we go along. I shouldn't say that. That'll make you blow it off. Huh? Many programmers avoid global variables to minimize errors. You should try to avoid global variables, but sometimes they make things much easier. I don't see anything here that we need to use. We've already covered all this kind of stuff. Declarations, module calls, input and output. It's no different than what we've done in our last flowchart. If it seems like I'm going through this stuff fast, it's because it's already stuff that we've talked about, like in 2 other classes. Do read it again. Housekeeping tasks are stuff that you must perform at the beginning of the program to get ready for the rest of it. You have to define pi if we're going to use pi that way. Pi is also defined in a library. You can do import math and then call math.py. That's a more precise way of doing it. We'll start to do that. And then you have loop tasks that do the core work of the program. Most programs do loops. Rather than just run once and spit out an answer, loop until the user is done. And then end of job tasks are stuff that you do at the end of the program to clean things up. Housekeeping tasks are not only constants, maybe you need to open a file so that you can write from the file or write to the file or read from it. And then you loop, you do some calculations, you add up the people's salaries or whatever, then you close the file and print out the result. Opening the file was the housekeeping, printing it out and closing it was the end of the job. Housekeeping. Declarations and housekeeping. It's the stuff that happens up at the top. Then we have a loop. Loop continues to repeat. Something to notice about loops, and I've mentioned this before. My preferred flowcharting style, which I've kind of stopped using since this semester since the book doesn't show it, is to draw the line back up to the while loop like that, hooking back up that way. The book shows it going like that, but that introduces a possibility that you might make a mistake. The mistake would be is if you drew the line up here. You can't do that in a structured programming language with a loop statement. You can't just arbitrarily come back up and start doing this stuff again. The line can only go immediately above the while statement or directly to it. If statements don't have loops, they just break apart and then come back together. The while statements, they have a line going back up to the top, but if you draw a line going too far up where it's doing some other blocks before it gets to the while again, before it gets to the decision again, that's called spaghetti code. And you can't write it in a lot of languages. Some languages have go-to statements which let you do stuff like that, but this one does not. Most languages do not allow that anymore. That's 70s style programming. Instead, we use loop structures, and when you're doing a loop, you make the line either go back directly to the diamond or at least only directly above it with no intervening blocks. Here's an example of that. I'm not going to zoom in on this. Well, I guess I could. The housekeeping and the declarations. They're counting declarations as something other than housekeeping. Okay, fine, because they put it in a module. If all these variables were defined in a module, you wouldn't be able to use them in the main program. So the declarations were things like declaring your name, declaring what you want at the top of the report, declaring what you wanted at the end of the report. Then you did some housekeeping like open a file or ask the user for a name. If that name is not equal to quit, then you get that information or you do something with it. You get some information, you print it out to the report. Then you ask for the next name or you read the next line of the file. Is that name still not equal to quit? What if quit is a valid name and, in somebody's language, like Inuit? What is your name? Quit. So anyways, and then it keeps repeating as long as the name is not equal to quit. When it finally is, we do the end of the job. What is the end of the job? It probably prints out, the end of the report line. Then there was some stuff over here in the detail loop. Output the header. Well, that seems like it's a different flowchart entirely. Some programs, MERS, would not bother to create a module that contains only one or two statements. They would keep that in the mainline logic. If it's a formula, though, go ahead and stick it out in its own module because you may. I'll give you an example of why you might. Even though BMI is just one line of code, sometimes, because you can define it with this equation. By putting it in a module, you can make just one fix to it. What if somebody decides that they want this to be metric? Well, the formula for a metric BMI is completely different. So they might have repeated this code in 7 different places in their program, if it wasn't in a module. But if it's in a module, you only have to fix one place. I could go in and write the metric version of this instead. So even if it's just one line of code, if it's an equation, it's not a bad idea to put it in its own module. Now, am I going to insist you do that? No, but on some of our conversions, we did that, I think. Calculating from, feet to kilometers or whatever we did. Pigs to cows. So here's something new. I believe here's something we have not done. A hierarchy chart. A hierarchy chart looks like this. It displays one module, and then it displays how that module calls other modules. In the code on the prior flowchart, the main program called a housekeeping module, it called a detail loop, and it called another module. I don't use hierarchy charts. I haven't taught them before this semester. I'm doing it because this textbook shows them. But it's not a bad thing to think about. You know, and if the housekeeping module called another module, great, you would draw it underneath. If the detail loop called another module, you'd put that underneath. What if they both called the same module? Well, you'd probably, you know, put that module hanging off each one. I think they show an example of that in a minute. Here we go. Here's a more complicated one. The main program calls housekeeping. Housekeeping also calls detail loop, and it also calls end of job. Now, housekeeping has one module that it calls called get order. Detail loop calls one called process order. But process order calls 3 different modules. And that module calls one of its own. Now, this doesn't show it if they if the same module is being called in more than one place. If it did, you just draw another line. Like if get summaries also called compute tax, it looks like you should draw a line from there to there. But really, they just draw it dangling off. I believe that to be the case. I'm not going to ask you to draw any hierarchy charts. I just want you to have the idea. Just like a CEO, you know, and the CEO is you know, in control of the, you know, of the other people who work for them, and then the, you know, the lead engineer is over a team of people. You know how that stuff works in the business world. You have that in your brain. Program comments. It's a feature of good program design. You use your comments where appropriate. Identifiers should be chosen carefully. Don't just use single letters like I've been doing in my examples. Make them actual words that make sense. You should write clear prompts and echo input. Echoing input is when you display as part of your output what the user typed in. So your output repeats the input. Like you say, enter the miles to convert, and they type in, you know, 10 miles. And so the output says 10 miles is 16 kilometers. Did you have to say that 10 miles was equal to 16 kilometers? They just typed in 10. No. So in a short program like that, it's kind of not necessary. But what if, you know, enter your address, right? And then you go through a sales page, you know. You go through a payment page. Then it prints out a receipt. We're talking online. The receipt is going to include the address. Right, so that you can eyeball it, make sure that you got the right shipping address on it. And if you didn't, then you hurriedly try to cancel your order, or, you know, revise it or whatever. Right, so we echo the address in the shipping statement. What's another reason for doing that? You know, input height, input weight. You know, and they type in, you know, 60 inches for height. They wouldn't put 60. You know, input the weight. You know, you weigh 120 pounds. And then it says BMI is, and I'm just going to make up a number because I don't know what it is, 24. Whatever, you know. So that's great and all that, but what if it said this? Your BMI for 60 inches and 120 pounds is. This is a lot more useful. Why? Because what if it said you had a BMI of 240 and you looked at the chart and that, no, that's absolutely insane, it's off the chart. You'd have to go back somewhere and figure out, you know, what you entered wrong. But if this information is echoed on your output, then you can eyeball it immediately. Oh man, I typed 600 inches, you know, or whatever, you know, or I typed in 12,000 pounds rather than 120 or whatever. If you make any mistakes in keying your data, if it's echoed, then you can figure out immediately what you did wrong. Also makes it easy, right, to just copy and paste if you wanted to paste it in an email because you needed to tell somebody your BMI for some reason. So echoing output is a good idea. I haven't been asking you to do that because it's just extra printing. It's extra work for us, right? We haven't really been printing out 3 different numbers in the same line. Here's how that would look in Python. Print your BMI for, end quote, height, comma, quote, inches, and, comma, weight, comma, pounds, is, comma, BMI. That's what it would look like. That's a lot of typing, so I haven't been I'll do echoing of output. But you can probably see how that works, right? It's going to print that out, and it's going to follow it by the height variable, and then it's going to print out inches and, so that it can then print out another variable. The variables are not part of the parentheses, because otherwise it'd print the word height. Excuse me. They're not part of the quotes, because we don't want to print the word height. We want it to print the value of it, so we put those outside of the quotes. And we have to separate the individual parts of the print statement with commas. So that's how come we came up with that syntax. I'm sorry, it's too far off the code, off the page. In this language, you can separate them like that. If you get to a print statement and you feel like continuing it on the next line, you just put a comma there and you go to the next line. That's legal Python. Legal in a lot of languages. Python is picky about your tabs, but I think that works regardless of how you tab it. We could prove it. Not going to bother. Because your screen doesn't have the fonts as large as mine. You can easily fit all that on one line and still make it readable. Using program comments. Comments are ignored. They're just for our purposes. You could leave them off, but if you leave them off, you're not a good programmer, because you need to explain the complicated parts of your program. You need to explain what the program is doing. Professional programmers working in a team, if you didn't use comments, you'd get fired. So syntax differs among programming languages. In our language, we use that. Other languages use that. Other languages use that. Hey, sorry, not an arrow. Thanks, PowerPoint. Like that, to open a comment, and then to do that to close the comment. Something like that. I could be getting that one wrong. But anyways, you get the idea. When you're eyeballing the code, it becomes blatantly obvious what the comments are, right? Because they're written in colloquial English, and they're tabbed weird and stuff like that. They don't look precise. Flowcharts. Use an annotation symbol to hold information that expands on what is used within another flowchart symbol. Now, they didn't even demonstrate an annotation symbol, did they? Why don't we Google up annotation symbol flowchart? I don't see one there. These are valid flowcharts for our programming language. I'm assuming that it's like what we used with the curly braces. That's how I annotate my flowcharts. You need to put extra information and not put it in a block, put it in curly braces. What's a good example of that? Sometimes people draw flowcharts like this. I should have Lucidchart already open by the time we start class. This isn't going to be an assignment that I have y'all turn in. This is just an example. If you drew a flowchart and it got some input and then it did some calculation, I'm not going to fill in the things. And then you were going to calculate BMI, you would not do this. Calculate BMI. That's more of a comment, right? And then actually do the formula. BMI is equal to, whatever, weight divided by height times 703, whatever, right? You don't put both of these. You either just leave a generic, calculate BMI, and that means then a miracle occurs, we're not going to say how to do it. Or you do that. You don't put both of them. Why? Because they're not two separate steps. They're just one separate step. So if we were going to do this one and not do it like that, we could put an annotation out there. For, English units, BMI is equal to, and you put the equation there. That would kind of tell us extra information about it. That serves as a comment. Or if you delete it, you don't need a comment. You don't need a annotation block. You just do that. So if you turn in a flowchart and it's got two blocks, and for a calculation rather than one, because you put a comment above and then you did the calculation itself, I'll ding you just a few points. It's not like you failed flowcharting just because you had two blocks. But that's by far not the most serious error you can make in flowcharting. The most serious is if you have a dead end. If you have a if statement and then it runs off to the side and then it doesn't do anything, whatever, that's a dead end. That's not a valid flowchart. That's big points off your flowchart, not little points off your flowchart. So no dead ends in your program. They'll all eventually have to work together to get to a final terminator. There's an exception, and I'm not going to mention the exception. Okay, I'll mention the exception. You know that return statement? Your module could conceivably have more than one return statement. Ours aren't going to have that right now. But it could do something, it could perform some calculation, and then if there was an error, you could return an error state right away. Else, keep doing something good, right? And then have one more terminator, which is, return good value, whatever they calculated. This is valid programming. Some people would argue that it's not the best programming, but on the other hand, some people would say it's just fine. You're allowed to have more than one return statement in your modules, so you're allowed to have more than one return statement in your flowcharts, but not in your main code. In your main code, they always have to end up at a stop, however they do it. And really, this process should not go back there. It should hook up like that in a little circle, just as we've done in the past, right? Like that. The connector is what that's called. If statements always have to hook back up, like that. I know lecturing too much makes people get bored. That's why I usually have us do some flowcharts of programs after a while. We're going to get to the point pretty soon where we do that. Oh, there's our annotation symbol. I like it. If you want to do that, that's fine. We haven't shown how to draw dashed lines, but you can probably figure it out pretty quickly. But, it's almost the same as what we were doing. It's just it has the lines going all the way to the end and not curly like ours. If you like doing that, I don't know how to do that in our program, so I would use the curly braces. You figure it out, more power to you. Annotations are for comments in your flowchart, same idea. We've talked about guidelines for variables. They need to have good names. Can they start with numbers? No, they can't start with numbers. Can they have spaces in them? No. So identifiers are both variable names and module names. Cannot start with numbers. Cannot have spaces. They can have underscores. And they can be letters and digits. Some languages support other symbols like $signs and stuff like that, but Python's pretty picky. That's what they want. On the other hand, the letters could probably be in other languages. If you speak Russian and have a Russian keyboard, you could probably make your variable names in Russian. It wouldn't be fair not to. But that's counted as a letter, right? It's just not a letter in English. So your general guidelines. Variables should be nouns, right? Height, weight, and stuff like that. And modules should be verbs. At a certain point, if you get to C# programming in another class, which I recommend, it's an awesome language, then you can make modules that are nouns as well. Then it's a specialized case. So what does that mean? Weight is a noun. So is height. Calculate BMI is a verb. Here's a rule. Use the system your language allows to separate words into long multivariable names. What does that mean? You could do patient BMI, that's a valid variable, or you could do patient BMI like that. Or if you just refuse, you could do that, right? These are all valid. This is preferred nowadays. It's called camel case. It's a punny name, but it's official because it's got a hump in the middle, right? Got an uppercase letter. Underscores are also cool. They're old school. Both are cool. I like these rather than these when I'm teaching in class, just because I know that if I type patient BMI, then somebody's going to leave that as lowercase. You know, it's going to introduce typos. Underscores are much less likely to cause typos when I'm wandering around. So, but just remember, if you want to be a pro programmer, especially in Java, all Java programmers follow that one because the inventors of the language did. And the same is true for functions. You could do calc BMI, that's a valid function. You could do calc BMI camel case. If you want to be a rebel, you could do that. And then the textbook goes on to show some things that either don't work in this language or that nobody does. Calc BMI doesn't work in this language. Why? Because it thinks a minus sign is a minus, right? Not a variable name. No. And then calc BMI like that with a capital letter. That's known as Pascal naming. We're not programming in Pascal. You can leave that. So these are the ones that I want you to remember. They call this snake case, I believe. We'll go a couple slides forward, and I think they call that snake case. I've never used that term, but we'll make sure that that's the case. That's what it's called. Just pick one of the two. It's fair game for me to ask about camel case. I'm not going to use the term snake if something is too absurd. One exception to which rules you should follow: consonants should be all in caps with upper scores. That's why I always define pi in uppercase. Why? Will the program work? Yeah, sure. You could call pi, Fred or Lady Gaga or whatever. Just like I said, that's for our purposes, not the program's purpose. It doesn't care. But it's just tradition, dating all the way back to the 70s. Consonants should be all caps with underscores. By tradition. Am I going to count you off if you don't do that? Well, on an exam question, I may say true, false. Consonants should be all in caps, in which case that's a true. But if you turn in a program where you defined pi as lowercase, no, I'm not going to ding you for points. I'll put a comment in your feedback. Alrighty, we're getting close to the point where if we were going to do a program, we need to do so quickly. Using temporary variables to clarify long statements. If you have some calculation that's like 5 variables long, and it's got all sorts of parentheses and, mathematical operators and stuff like that, consider breaking it down into individual steps. I hope they give an example of that. No, of course not. Come on. Like this. You could use a single statement to clarify, to compute permission, and most people would probably, put all that in one line even. Or you could break it up. Base property price is equal to that. Total sales price is equal to that. And then your sales commission is equal to the commission rate times the total sales price. Right? These are known as temporary variables. Base property price is used to calculate the total sales price. The total sales price is used to calculate the sales commission. Why is that better than that? Well, that looks pretty easy. But what if, this was physics terms instead of, we understand pretty much prices and commissions in our head. What if you needed to debug what was going wrong and you didn't know why it was going wrong? It's harder to debug this because it does all the calculation in one fell swoop, and all you can do is get the answer. You could print out the answer and see. But if you use temporary variables, you could print the base property price. You could print the total sales price. And then you could eyeball it and go, okay, I see why the sales commission was wrong. It's calculating the total sales price wrong. Especially if you echo your input, right? So that's one reason to use multiple statements with temporary variables. Easier to debug. We've talked about clear prompts and echoing input. Every program you write will be better if you plan before your code. Now, the habit, especially when I make an easy assignment, is just to go, okay, I'm a wizard. I'm going to write my program. You ought to map it out. Get a piece of paper and draw even a crude flowchart. A big box that says input, and another big box that says calculate BMI. And then another one that says loop until BMI is less than whatever. That kind of thing. Just plan it out. Because until you become skilled at this stuff, you're probably not going to be able to plan it out in your head as you go along. And if you can, more power to you, but still, you got to plan it out before you start coding. Maintain the habits of drawing flowcharts or writing pseudocode. Desk check your program logic on paper. Now, nobody prints code out on paper anymore, but people still actually do that in what are known as code reviews. You sit down with another programmer, you print your code out, two programmers sit there, with you, and they go, okay, well, why in the world did you do this? No, this doesn't look like it's going to give you the right answer. No, this looks like it could crash if you entered a negative number. That's a code review. Think about the variable names and modules you use. Design your program statements to be easy to read and use. Just like if you're writing fiction, right? You could write a sentence that was, 50 words long. The English language supports things like that. But if you want the sentence to be understandable by the readers so that they enjoy it, you write it clearly and you break it down into shorter sentences and stuff like that. Same with programming. You want your program to be as easy to read as possible. Why? So that if you have to come back and fix it, you can figure out what you were doing. And trust me, if you look at code you wrote 5 years ago, it's going to be hard to understand what it's doing at first. So you better put comments. You better write your code clearly. That's why you use good variable names, good module names. That's why you use white space if you like white space. Some people refuse to do it. And that's why you use comments. Make your program easy to read and to use. Summary. Programs use literals. What are literals? Those are values that are literally typed in your code, like 703. Variables and named constants. In my programs, I probably should define a constant called BMI conversion or something like that. BMI English conversion. That's a lot of writing. And then when I calculate BMI, BMI is equal to height times weight. That's not I'm getting tired of typing the formula. Right, like that. Okay, I'll type it. I can't stand getting stuff wrong. weight, divided by height times the English conversion. Why would you do that? Because you might later on want to do a metric conversion. I don't remember what it is. Whatever it is, right? And then if you saw a formula, this is what's known as a magic number. If you have 703 up here. Some magic numbers are really obvious. That's a magic number that you would recognize, especially if I've had you type it in 4 or 5 times in a row. 703 is only magic if you if you were reading some code and you saw something multiplied by 703, you'd go, what the hey? I don't understand what that number means. Where'd you get that number from? Did you just make it up? Did you, that kind of stuff. So magic numbers should instead be defined as constants. So this is a named constant. I'm going to rewrite this, and I'm going to copy that, and I'm just going to change that to that. 703 is a literal. And we know that height and weight are variables. You can break down your programming problem into modules. We know that arithmetic follows the rules of precedence. You can use hierarchy charts to show the relationship. As programs become more complicated, the need for good planning and design only increases. A lot of our programming, once you get the idea of a conversion program, I'm not going to make you do a pseudocode or a flowchart for every conversion program you write, because the concept's pretty simple, right? You get some input, you do something to it, and you print the output. But the need for good planning and the design increases. If I gave you a project, and I want you to write a game simulator to where, 2 fighters in Pathfinder or D&D are fighting each other, that's a complex problem. You need to map it out in your head how to solve it. I probably wouldn't give you a flowchart or pseudocode how to solve it. Instead, I would ask you how to do that. And by the way, that's one of my scripting classes assignments. That's a little bit much for this class. All right, we are at the end of the chapter. We're pretty much out of programming time. Let me think if there's a sample program that I want us to do that I made the other class do that this class hasn't done. We've already done 6 of them. What did the other class do? Quite a few more. Okay, the stuff that they're ahead of you is stuff on Chapter 3, which we haven't hit. We've done modules. I think pretty much we're at a state of equality. So, other than the fact that they've gotten to Chapter 3. Why don't we cut the class a little bit early, but if you have any questions, we can hang out and do questions. Let's see what our next homework assignment should be. Yeah. Let's look at that assignment. Again, this is Chapter 3 stuff. But I'll just mention it. There are 2 kinds of decision blocks. There are single point decisions where you do an if statement, and if it's true, you do something. else you do nothing, kind of a null. And then there's double decisions, where if you make a decision, you output one thing, else you output something else. To remind everybody that they need to do a flowchart, excuse me, that they need to do the quizzes, I'm going to post them as, I'm going to make a homework box that says MindTap Test Chapter 1 and 2. And it'll have a due date. You don't even have to upload anything to it. That's just to remind you, go get that done. It'll have loops to it there. Alrighty, I'm not going to assign any homework. I think y'all are still set with something due tomorrow, if I'm correct. So I'll take roll based on taking attendance because we didn't upload anything. Sorry guys, I know you're trying to run out now. Alrighty, Alexander, Christian, Christian here? No Christian. Colin. Here. Devin. Here. Graham. Graham here. Haley. Haley here. Wow. Jeremiah. Here. Justin. Here. Good deal. Kyle. Here. Lucine. Lucine here? Nathan. You gotta be kidding me. Noel. I mispronounced your name. I apologize, Noel. Parnell. Here. Ryan. Here. Sarah. Sparks. Here. Taylor. She was here, wasn't she? She left early? Yeah, I know she was here. Tyler. William. William? Here. There you are. Okay, great. And Wyatt. Wow. It's like we had half the class missing. That's not good. That's correct. That's correct.
Okay, so you said for the test it's on MindTap, right?
Right.
Okay, I'm still unable to get access to MindTap.
Have you bought the book?
The book?
Have you bought the access?
On MindTap, no, I'm unable to. Every time I try, it just says like unavailable or an error. I went to the bookstore, they didn't have any codes. The only thing they had was the book that came with the code, but it's like $250.
No, that's not good. Don't buy the book that doesn't have the code. You got to figure out how to get the MindTap to work. If you want to try to do it here, if you have a credit card, then I can watch over your shoulder and we can get it to work.
When's the quiz due?
Next Monday at midnight.
Okay, that's fine. As long as it's not due until Friday, because I'm broken till Friday.
All right.
But I think if I go through MindTap instead of going through D2L to get to MindTap, I think I may be able to.
Okay.
Because from what it looks like, it's an error whenever it tries to move over to MindTap
Okay.
from it. But,
okay.
Yeah.
Well, I apologize you're having trouble with it. So yeah, go ahead and try to do it through MindTap itself.
Yeah, I didn't realize you were doing it through MindTap, because whenever you said you were going to post most of the stuff to D2L instead of MindTap because you had that problem.
Well, they are.
Yeah.
They're
posted. I didn't realize we were doing anything else with it, so I just ignored it.
Yeah, so we have the 2 exams. You can find the MindTap links here.
Okay.
I need to remove that one now.
Yeah, because I mean, I still have the book. I just don't have MindTap because whenever I was ordering my school books, I wasn't paying attention. I was like, oh, I'll just order this book.
Right,
and then like 3 days later, I'm looking at it like, wait a second. I need this, not that.
Yeah.
Okay, thank you.
All right, sure thing.